Continue in this video, we will talk about example for the carry flag and overflow flag. So you can see the definition here. We say carry flag set when unsigned value is out of range. Overflow flag set when signed value is out of range. So we know the carry flag will focus on unsigned value, but overflow flag will focus on the signed value. So that's detailed to talk about unsigned and the signed value. And remember your assignment 4. I asked you to declare 5 different variables in unsigned and 5 variables in signed value. What did you discover in the watch window? So one thing is we need to know all CPU instructions operate exactly the same, no matter it's signed or unsigned integer. Because one thing is, remember we told you, in the register, EAX, EBX, ECS, those all-purpose registers, they only have 4 bytes. What value they work on, they don't know that's unsigned or signed. But no matter what, their result for the calculation should be correct. So that's why the CPU at that time when they process the data, they are not really know, they cannot distinguish between signed or unsigned integer. They just process the data in the location. Actually, is the programmer you are solely responsible to using the correct data type for each instruction. So what does that mean? We see here is the watch window from your assignment 4. Remember, I asked you to declare the value A, value B, value C, value D, and the sum are unsigned integer. And you can see here, your watch window, you have EAX, EBX value, and they are unsigned as well. Then you declare X value B, X value C, X value D, and S sum as signed integer. So when you try to using exactly the same value to perform sum equal to A plus B parentheses minus C plus D parentheses, that's your output. Right, if they are positive number, signed integer or unsigned integer, they display correctly. Then you guys have question about that, right? Because for example here, the value A and the S value A, we both assign equal to negative 200. But in the watch window, you don't see that's negative 2000. You can see signed value A display negative 2000. But value A didn't display negative 2000. But you did assign the value is negative 2000, right? The reason is value A did store negative 2000 correctly in the binary format. But when you display the value on in the watch window, when they try to interpret that value as unsigned integer in the decimal number, they become a weird big number. That's just because your value A you've been declared as unsigned. So when they try to interpret that 4 bytes, they will become this big value. So that's why if you're using for the display watch window in the decimal format, you maybe see value A and S value A, they holding look like different value. But the watch window, remember, you can right click on the watch window. Then on the toolbar, they show you, you can choose to display in the hexadecimal format. So now we see again. In the hexadecimal format, did you see they are all the same? Right, so that's why I want to show you. Because your value A, S value A, you both assign equal to negative 2000. So when they translate into the hex or binary number, they look like this. They are exactly the same. But because when we do the watch window, we want to display in the decimal format, they will according to, oh, this one is unsigned integer, so I display like this. So then this one is signed integer, so I display like this, equal to negative 2000. But no matter you are signed or unsigned, all the CPU instructions operate correctly. So that's why you will see at the end, your sum or as sign, they are the same. So this one actually is what I want you to see in the assignment 4. Your assignment 4, ideally, when you want to define your memory operand, you should know you want to use that to calculate signed number or unsigned number. So that's why you can declare correctly for the format. Then anytime, no matter you are using for the watch window or display in the console, they will display correctly. However, even you didn't declare them correctly, CPU still can make the value you move to EAX, EBX. Actually, we just consider they are unsigned. They will still be calculated correctly because the format and the CPU instruction, they will operate exactly the same how they do the sign and unsign. So the sign and unsign actually for the CPU, they have no idea. It's only the programmer we know what we're trying to work on. So that's why I want you to remember this about the signed and the unsigned integer. So then we can continue to talk about the carry flag and overflow flag. So pause the video anytime to write down the question if you have. After you understand the signed and unsigned integer, how you will declare in the variable, let's see how the instruction will affect overflow flag and the carry flag. So the first thing, let's see the add instruction. So we have add instruction. They will affect overflow flag and the carry flag. So how you will decide? The carry flag will according to, will you carry out the value from the most significant bit? So if your most significant bit after you add, right, they need to carry out 1 afterward, then your carry flag will be set. So that's the carry flag. So then the overflow flag is, we're using the carry flag value inclusive OR. Okay, so do you remember what is inclusive OR? Yeah, we talked about a little bit, right? Inclusive OR is, if you have the table for inclusive OR. So that's inclusive OR truth table. When you have two inputs, if A and B, if A inclusive OR B, only one of them is true. The result will be true. So either both of them is true, that will be false. Or if both of them are false, they will be false. So only one of them is true. So then the result will be true. So that's inclusive OR. So after you understand inclusive OR, overflow flag is using the carry flag, inclusive OR, with the carry into the most significant bit. So that means, do you have any carry into the most significant bit? On the other hand, that's the bit on the right for the most significant bit if they will carry in. So that's how we decide the overflow flag. So that's the math calculation, how to see that. So actually underneath, they have very important math reason, but that's how we decide the overflow flag. So then when you do a sub instruction, how they affect the overflow flag and the carry flag. So one thing is, for the carry flag, you just see, do you carry out from the most significant bit or not? On the other hand, you don't have enough to subtract. Do you need to borrow? So that's a carry flag. So then here, overflow flag actually is the same. So overflow flag always depends on your carry flag value, inclusive OR, the carry into. So be careful, it's the carry into the most significant bit. So on the other hand, it's the bit on the right hand side for the most significant bit. So that's the carry flow flag and overflow flag. So to help you to understand, let's see this example. We just say, for example, we have the value, these two numbers we just add, right? So when you add, you see 0, 0, 0. So 1, 1, 1, 1. But here you see 1 plus 1, we carry out, right? So that's why carry flag is 1. So the CPU used an interesting mechanism to determine the state of the overflow flag after an addition or subtraction. So the first thing, after addition and subtraction, definitely we can decide the carry flag. So then after you decide the carry flag, right? So then remember we say the overflow flag is carry flag inclusive OR with the carry into the highest bit result. So this one is the highest bit. So then we see if they have value carry into. So that's why I see 0 plus 1 equal to 1. Do I carry into the most significant bit? No, I don't have value into, right? So the carry into will be 0. But then because your carry flag is 1, 1 inclusive or 0, they will become 1. So that's why here your overflow flag at the end will become set. So in this example, your carry flow flag and your overflow flag, they both are set. So that's how we decide the overflow flag and the carry flag. So then you actually understand that. Let's see more example. For example, we see this one. So we have AL, we have the value FF. You add AL with the 1. So then what the result is? You see FF plus 1, you see you carry over 1, right? So carry flow flag is set. So AL equal to 0. So then when you have your AL equal to 0, you sub AL, 1 from AL. That's why you see 0 minus 1, you don't have enough to minus. So that's why you need to borrow from the previous bit. So that's why carry flow flag both are set for this example. But this one is the carry flow flag if we just consider that's unsigned. But one thing is the same thing. If this one you want to see the overflow flag is set or not, then this one we need to see the FF actually is 1, 1, 1, 1, 1, 1, 1, 1 H, right? Okay. So then you see after you add 1, we need to see carry flow flag is set. So 1 plus 1 is carry over 1, carry over 1, carry over 1, carry over 1, carry over 1. So 1 plus 1 carry over 1. So that's why you see you carry over 1 into the most significant bit. Then your CF is set. So on the other hand, for this one, overflow flag is clear. And the reason is, remember we say the inclusive OR. So since they both are, carry flow flag is 1. So carry into the most significant bit is 1. So that's why overflow flag is 0. So then the same thing, this one. If we want to do the sub, you want to do the sub, the same thing. But here, the different thing is now your AL is 0. So they are 0, 0, 0, 0. Okay? So when you minus 1, okay, so you minus 1, you will need to borrow from the 1. So that's why here you see they borrow, so carry flag is 1. But then when you borrow that, so the most significant bit, the next bit not carrying to the most significant bit. So that's why here, this one, your overflow flag is set. So then make sure you spend time to see the example here and answer all the value we have here for the AX, AL, BH, AL. Then check your sign flag, zero flag, and carry flow flag, what is the result is. If you have question on that, we will go over this one during the Zoom meeting to make sure everyone understand that. So yes, even earlier we say overflow flag is carry flow flag, inclusive or the most significant bit. Actually, it's the carry into. You carry into the most significant bit inclusive or CF. But here actually we have a little easier way to remember that. When you add two integers, remember that overflow flag is only set when this thing happens. Two positive operands are added and their sum becomes negative. overflow flag will be set. So true negative